When tons of prehistoric muscle shatters the surface to snatch a target from the air, it resets the stakes of the entire story. This massive predator isn't a background detail. It's an immediate signal that the water is no longer a safe zone. That signal was most famously sent through the death of Zara in 2015's Jurassic World. The sequence remains a point of intense debate among fans, many of whom felt the character's prolonged, multi-stage demise was a jarring departure from the rest of the film's tone. While the film spends much of its runtime exploring the idea of taming dinosaurs through training, this sequence acts as a hard counterpoint. It strips away any illusion of human control, showing an animal that operates solely on a drive to hunt and feed. There is a specific narrative logic at work here. By demonstrating the animal's reach and power early on, the filmmakers ensure that when it reappears during the climax, its role in ending the fight feels like an inevitable result of its biology rather than a convenient accident. Zara's death effectively prepares the audience for the finale. Once we've seen the Mosasaurus dominate the lagoon, our brains are already tracking it as the ultimate solution for a threat that the T-Rex and raptors might not be able to handle alone. When human characters take a boat and a rifle onto the water to hunt an aquatic giant, the comparison is unavoidable. Director Gareth Edwards noted that during the production of Jurassic World Rebirth, he and his team had to actively work to ensure their boat sequence felt distinct from the shadow cast by Steven Spielberg's Jaws. The effectiveness of this approach was clear during an early test screening for the staff at Universal Studios. As the sequence played out, composer Alexandre Desplat sat up in his seat and remained in that position for the rest of the film, immediately telling Edwards he was ready to start writing the score. This moment represents a shift in the film's mechanics, what the director calls the point where the safety harness comes down. The setup is over, and the movie enters a state of continuous movement that doesn't relent until the credits. But as effective as this beast is on screen, it is still a construction of digital effects and creative liberty. To understand the animal, we have to look past the movie magic and find where the Hollywood monster meets the actual fossil record. To build a voice for a creature this size, sound designers couldn't rely on reptiles alone. They needed a sound that carried the weight of a massive body while sounding like something that actually lived in the ocean. The solution was a layered mix of modern marine mammals. They used the deep, heavy bellow of a walrus to provide a foundation of physical mass and size. On top of that heavy base, they added the higher-frequency clicks and whistles of beluga and pilot whales. This gave the Mosasaurus a vocal personality that felt distinct from land-based predators like the T-Rex. The final step was scale. While the real animals were enormous, the filmmakers chose to stretch their digital model to a length of 60 meters, roughly the size of 2 blue whales parked end-to-end. This cinematic Mosasaurus is a hybrid, built from the voices of modern mammals and proportions designed to trigger our fear of the deep. It is a creature engineered for the screen, not the actual Cretaceous seas. Outside of the theater, the data tells a different story. At the 5th Triennial Mosasaur meeting at Uppsala University, researchers focused on the biological limits that governed these real-world giants. In biology, every species follows a bow plan, a basic body plan. For a marine reptile, that plan has a hard ceiling. Biomechanical constraints, such as the strength of the heart and the ability to move through water efficiently, prevent a reptile from functioning at anything close to 60 meters. This scale shows the difference between the movie version and the historical Mosasaurus hoffmanni. Based on measurements from massive jaw specimens found in the Netherlands and Russia, scientists estimate the actual maximum length was between 17 and 18 meters. Modern whales only reached their current gargantuan sizes by becoming filter feeders. Mosasaurs remained active predators, which requires a metabolic and physical balance that naturally limits how large a body can grow before it becomes impossible to sustain. Hollywood might have bypassed the laws of physics for a more dramatic silhouette, but an 18-meter predator is still roughly the size of a modern semi-truck, a massive, specialized hunter in its own right. We can see how these hunters lived by looking at their internal architecture. By examining the 3D vascular systems in fossilized bone, paleontologists can track how these animals transitioned from land-dwelling lizards to fully aquatic specialists. High-resolution CT scans map the inner ear's bony labyrinth, revealing more about behavior than overall size. The semicircular canal's specific angles govern yaw, the ability to rotate horizontally. This structure proves the Mosasaurus could execute rapid, agile turns while pursuing prey. The true history of the Mosasaurus isn't found in Godzilla-sized proportions. It's found in a sensory system and a body plan that were perfectly adapted for high-speed pursuit in an open ocean environment. The reason these movie scenes resonate so strongly is tied to thalassophobia, the primal fear of what might be lurking in the vast, murky emptiness of the deep ocean. When a film exaggerates a Mosasaurus size, it isn't trying to be scientifically accurate. It is trying to speak directly to that evolutionary anxiety. It uses scale to make the deep ocean feel as intimidating as possible. Hollywood may have borrowed whale songs and ignored the laws of biology to build a blockbuster monster, but the awe we feel is based on an underlying truth. 66 million years ago, the oceans really were ruled by giants.